Hello there, computer science students. Your next mission is to write a program that uses the quadratic formula to solve, quadratic equations. So recall that the roots of a second degree polynomial, okay, can be found using the quad formula. And here is the quad formula. All right? You might have thought that your math teacher had a weird obsession with the discriminant. Okay, so they probably talked quite a bit about b squared minus 4ac. And the reason that they talked so much about the discriminant is because the discriminant is what controls the type of solution that you're going to get. Okay, so if b squared minus 4ac is greater than 0, then you are going to get two real solutions. Okay. Now, if b squared minus 4ac, the discriminant, is equal to 0, then you are going to get a double root. So we have a double root here, right? Double root. And I'll do examples of each one of these here in just a second. But if b squared minus 4ac is less than 0, then we have two complex roots. Two complex roots. And these are going to be the most difficult for you to deal with and how you are going to decide to output these double root or the complex roots. All right. So first, find the roots of x squared plus 7x plus 12. Well, the first thing I'm going to do is I'm going to find the discriminant. So the discrim is equal to b squared, that's 49, minus 4 times a. A is the lead coefficient here, that's 1, times c, and c is 12. Remember, a is 1, b is 7, and c is equal to 12. All right. So 49 minus 48 is equal to 1. So now that I know that it's positive, then I know that I'm going to have two real roots. So now I can say root 1 is equal to negative b, so that's negative 7, plus the square root of 1 divided by 2, okay, which gives me negative 7 plus 1 divided by 2, which is negative 3. Or, and now we have root 2 is equal to negative 7 minus the square root of 1 divided by 2, which would be negative 7 minus 1 over 2, which is negative 4. So your two roots in this case are negative 3 and negative 4. All right, let's take a look at this next example where we get a double root. Okay, when we look at the discriminant, so the discrim is equal to b squared. So I've got negative 6 squared, that's 36, minus 4 times a times c. So that's 36 minus 36, that's 0. So root 1 is equal to root 2 is equal to, now since the discriminant is 0 and the square root of 0 is 0, I'm just going to do negative b. So negative 6 divided by 2 times a, like so. All right, so that's going to give me what's positive 6 divided by 2 is 3. So I've got double roots. My double roots are 3 and 3. All right, and now for the most difficult case, and that's the complex numbers. All right, so now when I calculate the discrim, I get discrim is equal to b squared, that's 4, minus 4 times a times c. So now I've got a discriminant of negative 16. Well, now I know that I have two complex roots. Well, if I have got two complex roots, then let's see. The roots are, root 1 is equal to negative b, that's negative 2, plus the square root of negative 16 divided by 2 times a, and a is 1. So we have negative 2 plus, now, negative 16, the square root of negative 16 is 4i. Right? Now, the computer will freak out if you try to take the square root of a negative number. All right? So you're going to have to think about how you actually take the square root of a negative number in your head. When you take the square root of a negative number, you just take the square root of 16, and then because the discriminant is negative, you tack an I on the end. All right? It gets a little tricky when you try to program this, but I'm gonna let you guys struggle a little bit with this. All right, so root 1 is equal to negative 1 plus 2i. Okay, and we know that roots come in conjugate pairs, so root 2 is negative 1 minus 2i, like so. All right, so here are 3 examples that you have so that you know that your output, so if your input is 1, 2, and 5, A equals 1, B equals 2, and C equals 5, then your output should be negative 1 plus 2i, and then negative 1 minus 2i. Okay, I want to cover 2 other things about this program. First off, what do we do if someone tries to enter a 0 for A? Well, if someone tries to enter a 0 for A, we should attempt to stop them. So we're going to put an if statement in there. If A is equal to 0, then please re-enter A. All right? So the second thing I'd like to talk about is the flow chart for this program. All right, so let's take a look at this flow chart. The very first thing you want to do is you want to get A, B, and C from the user. Remember, we put input and output from the user goes into a parallelogram. Right? And then we're going to check to see if they entered 0 for A. If they did, we're going to ask them to re-enter. And then after they re-enter, then we're going to go ahead and compute that discriminant. Right? So if they didn't put in 0 for A, then we're going to go ahead and compute the discriminant like so. So from here, we need to make some choices. Okay, so here's the rest of this flow chart. So if the discriminant is greater than 0, if that's true, we're going to calculate root 1 and root 2, and then we're going to display the results. If the discriminant is equal to 0, then we're going to calculate the double roots, and then we're going to display the results. If that's not the case, so if the discriminant's not bigger than 0 and it's not equal to 0, it's got to be less than 0. So this is going to be our else case. Calculate the complex roots and then display the answers. If I were you, I would, when I'm programming, I would make sure that these first 2 cases work and then work on this third case because that's the most difficult piece here. All right. Thanks for watching and good luck with this program.